Hey guys, welcome to Gary's Ground School. Today we will be continuing Chapter 2, Section A, which was from last video. So if you want to go check that out, please do. Once again, timestamps are in the description. So if you want to skip ahead, I know it's going to be a shorter video, but if you want to, they're there. The first thing that I wanted to show real quick that really stresses how important relying on your instruments is the Nall AOPA report. So I believe it's more specifically called the Nall accident report, but it's very interesting to read and really wrap your head around what causes aviation accidents, how many of them are fatal, and whatnot. What I really wanted to show you is this statistic right here. You'll see that on landing accidents, such as missing the runway or going off the runway, 314 were non-fatal and 3 were. However, with weather, you have 42 that were not fatal and 32 that were. That's a very low margin, which means 9 times out of 10, if you go into IMC from VFR into IMC and you're not prepared, or your VFR airplane is not properly IFR equipped, 9 times out of 10, you're not going to make it out of there. So just real quick, if you want to look into that, that's really cool. What we're going to start with is how do we check our flight instruments before every flight? And then during taxi and whatnot, of course, we will be checking airspeed, attitude indicator, altimeter, turn coordinator, your directional gyro. Some just have an electrically driven heading indicator, and of course, your VSI. Before start, and this is very simple, really easy to see, you have your turn coordinator, which is on the left, and you have your attitude indicator, which is on the right. Before you even start the plane, before that engine-driven vacuum pump comes on, you want to have these red flags here. And you want to have your ball in the center. Your ball is your inclinometer, which reacts to the g-forces of the plane. But all it is, it's like no sort of mechanism except a ball suspended in a tube of fluid. That's all it is. Just think of a level, how you move a level left and right. That bubble is going to go left and right. So that's all you really have to do before start for your turn coordinator and attitude indicator. Now, after you start your aircraft, there's just a few things you want to make sure going on. Most aircraft have like a low voltage or a low vacuum indicator, but you can actually visually check that. Your ammeters, which is like the load of the electrical load of the aircraft, is very important when it comes to like your DG and other electrically driven instruments. And then your suction gauge is most important because some turn coordinators are actually suction gauge or a combination of both suction and electrical, but like really crucial instruments are your attitude indicator and your directional gyro, because if you don't have that suction gauge, it's not going to be good whenever you go for an IFR flight and then all of a sudden none of your instruments are working that rely on the vacuum gauge. The next, and once again really easy to check, is your magnetic compass. It should swing freely as you turn. Let's say we're on this taxiway at Bravo going more or less south. You want to make sure the compass is indicating the known heading. And let's say you're turning onto Charlie down here. You want to see that magnetic compass turn 90 degrees to the right. So main thing is swing freely and indicate known headings. So there's 3 main turn instruments that you need to know about, that being your rate of turn indicator or your turn coordinator on most planes, your directional gyro or heading indicator, and your magnetic compass. When it comes to your turn coordinator, after the engine-driven vacuum pump is already producing its suction, everything's good there, you want to set it to the known heading of your magnetic compass. And then, of course, like I just said, you want the directional gyro to indicate known headings along with the compass. So let's say if this directional gyro was set to north and we turn east, you want both of them to turn to east, swing freely, and indicate known headings. And then, of course, you have your rate of turn indicator. You want your rate of turn indicator to indicate a right turn, or if you had a turn coordinator, you have wings level here, you want it to indicate a turn to the right. And then your ball wants to move outside of the turn, because think of it, a plane is stuck on the ground. It doesn't have that 3-degree freedom of motion. Think of it like a car. Whenever you're turning in a car, your body tends to go to the left outside of the turn. That's exactly what's happening here, because the plane can't yaw to the left due to it being stuck on the ground. I might have just stated this, but with your attitude indicator, your gyros actually have to have time to spin up. And this is the same for your directional gyro. As that vacuum pump starts to get powered by the engine, it usually takes about 5 minutes to get reliable readings on your attitude indicator and other gyroscopic instruments. Right here, we see the artificial horizon. You want to make sure that artificial horizon right here, not the orange wingtips, but the artificial horizon, You want to make sure that artificial horizon is erect and stable after 5 minutes of starting the aircraft. And then of course you set these little wingtips with this little knob right here to that artificial horizon. One main thing you got to know, and of course this is on your written test, whenever you're making turns while taxiing on your attitude indicator, you don't want that artificial horizon to bank more than 5 degrees, or that's going to cause your plane to not be, IFR worthy, because your attitude indicator is technically busted and it's not working properly. Because 5 degrees of bank in IFR flight is actually a lot, believe it or not, with how precise you have to be. Once again, we have your directional gyro right here. And much like the attitude indicator, you have to wait 5 minutes after you start the aircraft for your engine-driven vacuum pump to come alive, stabilize your instruments. Once again, you set, whenever you're on the ground taxiing or whatever, you set this directional gyro with this little knob right here to your known magnetic compass heading, and you're good to go. However, in flights, as we know, the compass has a lot of errors, and especially in turns and banking and a banking turn, let's say, that compass is not going to indicate the accurate heading. So it is best practice every 15 minutes to set your directional gyro to the compass heading when the aircraft is in straight and level, unaccelerated flight, so you get the most accurate magnetic compass heading. Next, we have our altimeter. What should you set it to? You should set it to whatever the barometric pressure is on your METAR, your TAF, or your ATIS. And whenever you set that, it has to be within 75 feet of the known airport elevation. However, if you're just out in the middle of nowhere, this private airport, it is legally allowed for you to set it within the elevation of that airport. Let's say on your sectional chart, it says 300 feet. So you just set it to 300 feet. And of course, when you climb out, you make sure that longhand is indicating a positive rate of climb. The next one we have is the vertical speed indicator, which this one is not required for IFR flight, of course, but it's still really nice to have, especially when you're doing standard rate climbs and descents. The main thing you got to think about this though is notice wherever it is reading. So for example, this is reading 0, so it's fine. But if it was reading negative 500 feet a minute, you would make that as your 0. So let's say you're descending and it's reading negative 1,000. That's actually going to be negative 500 from negative 500. And if it's reading 0, that's going to be reading a positive rate of climb of 500 feet a minute, which is completely fine. But remember, it is not legally required for IFR flight. Next we have, and this is just a brief overview of how they work and what to look for on these instruments. You have the primary flight display and the multifunction display. Multifunction display is usually on the right. Primary flight display is on the left. Now, how these work, it is not an engine-driven vacuum pump anymore or pedostatic system. It is actually electrical instruments such as your attitude heading and reference system, which roughly corresponds to your vacuum-driven instruments, and your air data computer, which roughly corresponds to your pedostatic instruments and is going to give you that pretty much same exact data, but usually a lot more accurately. Now, if you look on a PFD, it contains all the same flight instruments as you had before on your 6-pack. Airspeed indicator is right here. Attitude indicator is given by this artificial horizon versus the little winglets of this miniature airplane. The slip and skid indicator is given by this little bar that is under this larger bar, which indicates if you're slipping or skidding, of course, hence the name. And you also have your altimeter, which is this tape right here that goes up and down. You have your vertical speed indicator. For example, this is reading 600 feet per minute down. You have your turn rate indicator, which is given by this little blue strip. And if you're using a G1000, it's probably going to be a magenta strip. And if it is outside this, see this little bar right here? That is a more than standard rate turn. So in IFR flight, 9 times out of 10, you're going to be wanting to keep that little trend indicator right here on this line. And of course, you got your heading indicator. For example, right now we are on a northeasterly heading. So that is all your instruments you need to know there. Of course, you have your ILS localizer and glide slope and GPS course guidance. It's going to look different on a G1000, and I really encourage you to find a G1000 sim that you can use. I'm pretty sure they have electronic ones that you can download for your computer or iPad or whatever. With the G1000, your glide slope is going to be right here as well. However, it's going to be a little magenta diamond, and your localizer is actually going to be down here. So keep those in mind, but anything you're confused about, you can look up really good in-depth YouTube videos. Like I watched this 2-hour G1000 video because I was transitioning from Steam to Glass Cockpit, and I was actually really nervous because I was so used to Steam. I'd done like 80 hours before then. But of course, Glass Cockpits are superior. It's just they lead to complacency and whatnot. You also have your trend arrows, which are located right next to each instrument. So altimeter, you would be on a negative rate of descent. Your VSI, also this little trend indicator, you would be, once again, negative rate of descent. Airspeed indicator, you would be losing airspeed in this case. And you have one more trend arrow. It's not really an arrow, it's that strip I talked about that gives you your standard rate turn right here. It's blue or magenta, whichever one. You also have a moving map on your MFD. So we're moving over to MFD, which is to the right, which moving map greatly increases situational awareness, because when you're trying to visualize in space where you are with just a 6-pack and nothing else, it can get kind of overwhelming sometimes. But this, I will admit, makes everything so much easier. You have terrain, which right here, this is negative 100 feet, this is negative 1,000 feet. So most likely you got some hills and mountains over here. You got aeronautical charts, which I found it the coolest thing. I actually pulled up a VFR sectional, and it was just like looking at a VFR sectional. I don't know, it's the coolest thing. Because when you train on steam gauges, you kind of find this just to be amazing, and I do. You also have weather if installed. Some aircraft don't, but mostly if you have ADS-B in, you get that FISB information service that goes to your aircraft and gives you weather information and whatnot. Traffic if installed, once again, ADS-B in will give you that information from other ADS-B out aircraft in the area. Lightning strikes, which are really cool to look at, and really give you a good visualization of where Thunder's cells are located. So let's say there's a cell over here, probably a multi-cell looking like, and a cell right here that you can watch for and really know where the intensity of the thunderstorm is. Next, we have a flight plan, which is located on your PFD, which is incredibly important to know how to properly and effectively and accurately change during your flight, because amended routes are a common thing in aviation. You're flying from point A to point B, but all of a sudden the controller wants you to fly from point A to point C to point B. You got to know how to change that, and if you're not really proficient with it, there's a good chance that you might enter in the wrong fix, which could just destroy your situational awareness. You get lost and crash. That would not be good. And the G1000, of course, looks different than this, but it still gives you your same information, such as RPM, manifold pressure, power, oil temperature, and oil pressure. So your MFD is going to give you your engine and systems. And what I love, and I haven't actually seen it in practice, is with the old 6-packs, like it would be really hard to know which instruments were failing, because of course you got those conflicts, but they're not as pronounced as you would think in actual flight. However, with your PFD, it just draws a big old red X over which instrument is not working, which lets the pilot diagnose the problem a lot sooner and know what they have and really jump to resolutions quicker, instead of just thinking your airspeed's working when it's really not. However, with all this informational technology, cool stuff, easy to use, it leads to complacency, which is a big thing to watch out for, because let's say you're flying from point A to point B, got all your charts pulled up on your screen, you're on autopilot, that can really just cause your mind to wander, and you're just chilling there, and then ATC is talking to you, and all of a sudden you're complacent and behind the aircraft. So just watch out for that, which is why learning on a 6-pack is so useful, because you're always on top of things, making sure you're as safe as possible. However, and you'll see this on your written, this exact phrase, this tempts pilots to operate closer to personal or environmental limits. And you'll see, and going back to weather, you can see weather off to the left, to the north, whatever. A lot of pilots will actually, and I say a lot, a few pilots will actually operate a lot closer to thunderstorms than they would if they didn't have the equipment, of course. But the thing with radar is it only predicts precipitation. It never predicts like cloud cover. So you could have a microburst ready to, burst at any second, destroy your aircraft, and not even know about it because you're relying on the radar. So the very last thing, integrated flight displays may present new hazards and its limitations. Main thing to be aware of is just complacency. You don't want to become complacent knowing these you don't want to become complacent using these instruments. You really want to stay ahead of the aircraft in every way and really know how to use all of the equipment on board. So I really urge y'all to go get a G1000 sim or even Microsoft Flight Simulator. The new one you can get for $1. Of course, you have to apply for the subscription, but you can of course cancel that. So that's what I actually did. I bought that for $1, downloaded it. It was a massive game, of course, and used the G1000. And I actually went to my very first lesson, and the instructor was like, "Wow, you're pretty good at using this." So keep that in mind. Get proficient with everything that comes your way, and that goes with anything else, you know. But anyways, I hope I helped some of y'all. I hope y'all have a great day, and I'll see y'all in the next one.